Alright, so far we have factored using the GCF. Now we're going to be looking at factoring trinomials. At the end of this lesson, you'll be able to factor a trinomial with a leading coefficient of 1. Alright, we're first of all going to do just a review problem. This first problem says to simplify, and if you'll remember from this one, we are actually going to multiply these two binomials together, and I will do it both methods if you'd like to. When I do that, I'm going to, if I distribute the x, I'll get x squared minus 6x. And then if I distribute the 2, I'll get positive 2x minus 12. And then if I combine my terms, I'll end up getting x squared minus 4x minus 12. So if you remember, that was just two binomials. And if you look at this, it actually turned into a trinomial. And actually, when it turned into a trinomial, the leading coefficient would be 1 because 1 leads the problem. Right, what we're going to be doing is factoring a quadratic expression. So we're going to factor a quadratic expression, means to write it as the product of two linear expressions. Now, if you recall, when we were factoring before, again, we were just looking at a product, just like if I had 8, 4 times 2, that is factored because it's factored into a set of a product of two of its factors. All right, basically what we're going to be doing with a quadratic expression, and remember quadratic would mean the highest power is 2, so it's going to be a trinomial, 3 parts, the highest power will be 2. We'll basically be starting at the answer and looking for the problem. So in this one up here, we would actually start with this. It would say to factor this expression, and x plus 2 times x minus 6 would be my answer. So we're going backwards. All right, let's just go ahead and jump in on some examples. We've got x squared plus 3x plus 2. What I'd like to do, this is a trinomial because there are 3 parts. The degree is 2, so it is quadratic. So I know that I'm going to break it up into a product of 2 linear factors. I do know that this is going to have to be x times x because when I multiply x times x, I do need to get x squared. What we need to figure out is what's going to go here, plus 3 plus 5 plus 2 plus 9. What is that going to be? So the way that I'm going to show you how to do that is just a trick that works, so that's why we're going to do it. All right, so the leading coefficient is 1. I'm going to put a 1 there, and then we're going to take the first number times the last number, and we're going to multiply them together. So 1 times 2 will give me 2. And then I'm just going to list all the choices of what times what would give me 2. Well, 1 times 2 would give me 2, negative 1 times negative 2 will give me 2, and that's pretty much it. All right, so now the next thing that I would like to do is I want to figure out which one of those, when I added those factors together, are going to give me the answer in the middle, an answer of 3. And you'll notice here, if I did 1 plus 2, that would give me a positive 3, and that's exactly what I'm looking for. So I found my two numbers. I'll have a positive 1 and a positive 2, and I am factored. Notice I started out at the answer, and I ended up with the problem. All right, next problem, let's put a 35 here. Okay, on this one, same thing, it is a trinomial. The highest degree is 2, so I know that I'm going to break it up into a product of linear factors. We'll have x and x again, and then my trick is I'm going to put a 1 in front. I'm going to multiply the 1 times the negative 35. That's going to give me negative 35. And now I'm just going to write down choices what would equal negative 35. Negative 7 times 5, negative 5 times 7, negative 35 times 1, negative 1 times 35. All right, now I'm going to look at what these would give me when I add them. Negative 7 plus 5 is negative 2. Negative 5 plus 7 is 2. Negative 35 plus 1 is negative 34. Negative 1 plus 35 is positive 34. Okay, I wanted to get negative 2. So this choice does it for me. So minus 7 plus 5, and I am now factored. And again, one nice thing about these problems is you can multiply it back out. You can use your rectangle or whatever method you do. You can multiply it back out and make sure you get what you started with. Okay, problem 3, x squared plus 7x minus 18. All right, once again, it's a trinomial. It's quadratic, so I know I get to factor it into a product of linear factors. I'll start with x times x. 1 times negative 18 will give me negative 18. I'll list my choices. Let's see. Negative 6 times 3, negative 3 times 6, negative 2 times 9, negative 9 times 2, negative 1 times 18, negative 18 times 1. Ooh, all right. All right, so now look, if I did negative 6 plus 3, that would give me negative 3. Negative 3 times, and then positive 6 would give me 3. Negative 2 plus 9, excuse me, gives me 7. Negative 9 plus 2 gives me negative 7. Negative 1 plus 18 gives me negative 18. And negative 18 plus 1 gives me negative 17. Actually, that gives me 17. 17, not negative 18. Okay, because I'm adding, I forgot. Okay, so now I'm going to look at which one of those gave me the positive 7, and it's going to be this choice right here, the minus 2 and the plus 9. You will notice I'm listing all of the choices. Once you get good at factoring, you can stop as soon as you find a choice that works. You don't have to keep listing all of the factors. All right, let's say I have x squared minus 5x plus 6. Alrighty, it is a quadratic trinomial again, so I'm going to break it up into a product of linear factors. So x times x, we'll put a 1 in front. 1 times 6 is 6. If I list my choices, I have 1 times 6, negative 1 times negative 6, 2 times 3, and negative 2 times negative 3. Okay, 1 plus 6 is 7. Negative 1 plus negative 6 is negative 7. 2 plus 3 is 5. Negative 2 plus negative 3 is negative 5. I was looking for negative 5, so this one does it. Minus 2 and minus 3. Right, I'm going to try a couple more. I would like you to pause the video at this point in time and try these on your own and then come back and see how you did. All right, I'm going to put a plus 24 on this one, and then I will also put a 45 on this one just in case you're pausing and doing both of those at the same time. All right, on this one, since it is a quadratic trinomial, I do get to break it up into a product of linear factors, x and x. Put a 1 in front. 1 times 24 is 24. I'm going to start listing some choices here. 2 times 12, 6 times 4, 8 times 3, negative 2 times negative 12, negative 6 times negative 4, negative 8 times negative 3. I could probably keep going for a little bit, but I think I'm going to stop and look at my choices here. Alrighty. 2 plus 12 is 14. 6 plus 4 is 10. 8 plus 3 is 11. I'm going to stop right there because I was looking for 11 and I found it. So plus 8 plus 3. All right, and then the last one, we're going to have, it is a quadratic trinomial, so I'm all set to set it up like this, x times x, and then we'll take the 1 times the negative 45, that gives me negative 45. So my choices, negative 9 times 5, negative 5 times 9, negative 15 times 3, negative 3 times 15. I could keep going, but I think I'm going to stop. Negative 9 plus 5 gives me negative 4. Negative 5 plus 9 gives me positive 4. That's exactly what I'm looking at, so I get to stop. There's my choice. And voila, I am done. So hopefully now you can factor a trinomial with a leading coefficient of 1.